Awesome. And we're technically live. Very cool. I'm gonna pull it up on my phone super quick because we still have a minute, so just want to make sure. But hello, hi, welcome to the stream, to the oneleif stream.
Alright. Ready?
Yep.
Yeah, sweet. Yeah, I'm hearing it on my side.
Oh, okay. You always scare me with that. You playing that? I'm like, where is it? It's in the background somewhere.
Okay, we'll just do quick introductions. That way they know our voices.
Okay.
We don't have anybody new this time. I'm Sabian. I'm just really sick. I'm sorry if I sound awful.
Let's see. I do have it on the background. Oh, making me go insane, man. I'm Zach. I'm not sick. Welcome to the stream. The one and only oneleif stream. So we're just gonna dive into it because we got some other interesting topics for today. Right now we'll just go through the direction channel and see if there's any suggestions or anything. Oh, so yeah, we have a few. Did we talk about? I think we touched on these right for the last one. Or no?
Yeah, they're more than a week ago.
Yeah. Okay. But just reminding on them. I think that'd be great for the oneleif website. But yeah, we actually did start, so we'll be having the next one, and well, make sure that you stream or try to come along if you can, if you're close enough. But we'll be relaunching OneSwags soon. Are you doing a voting for that right now, or?
Yep, send it out.
All right, cool. So yeah, we're gonna do a vote, and pretty much whatever pulls the most, we're gonna order new stuff for clothing or anything like that. So if you do have suggestions, where should they put that, Sabian? Maybe in direction?
I'll edit the message and just tell them to add it below.
Alright, then that sounds good. You can put your suggestions in the voting channel for this vote, and we'll make sure to put a time limit on this, probably about a week or something. What do you think?
Yeah, we'll announce it at the next stream. How about that?
Yeah, alright, that sounds good. So, moving on, if that's all for direction channel, just a reminder that the direction channel is open for anyone to put any discussion or any suggestions that we should talk about for the weekly stream. So
Damn it. Should I put that in announcements? I'm sorry. So that way I could add everyone for it.
Well, I mean, you can link this post, like you can copy the link and then do an announcement, and then they go directly to the post, and because then, yeah, I think that's the better way to do it. So that's the direction channel. Cool. So active project stand up. Oh, I read that. I think we forgot to ask Will and Z for their little stand up.
I talked to Z. He said he's been swamped with school, but he's added a couple cool things.
Nice. Okay. Well,
he had like a custom node to his state graph.
I'll ask him. But you want to talk about the Swift, or not, what am I saying? That's my project. You want to talk about the website, the React?
Yeah, so this week I believe, so we haven't done any work on the back end in a while because front end is still catching up. On the front end, the React side, we have pull requests up for the custom carousel thanks to Fabrice. We have the register page being added thanks to T Northern. The media queries added thanks to T Northern, and then Will added the register page. I believe there was more, but those are just the ones that are waiting to be pushed in.
Okay, awesome.
Oh yeah, he updated the hamburger bar. We added the filter box, and then the basic card containers.
Okay, cool.
Lots of progress.
Nice. So then the next one for SwiftUIKit. Been really working on table views and getting like map views and other just nice views in there, but overall I've been using it in quite a bit of projects now, so I've gotten at least first-hand experience of using it, so I have a better idea on what to add and that stuff, but I'd love others' opinion. If you do want to dive in, you'll, after the stream and after going through it, at the end of the stream, you guys will have a better understanding of just basic UIKit and how to make iOS stuff, but then also SwiftUI, which is the new kind of DSL component way of writing UI, and then also state management. But so yeah, just adding tons of stuff to that. For OL Go, that's still in the block status of waiting for the designs for the website, because they're only for the website and not for mobile. So been waiting for that. The app, the iOS app OL Go, has actually hit the API for almost everything that the API supports, so that's just kind of where it's stuck at because it has no actual design to use any of that. So Bunny Hop is an interesting state. Why don't you talk about that, Sabian?
Yeah, so for those unaware, Bunny Hop is my 3D platformer that I'm working on. It just got to its second release, so I'm happy with like the way the movement works, the way the portals work, all that jazz. So I have like one last thing to fix with how you like surf, and then I can start adding in levels and release it on Steam. So pretty exciting stuff. I need to make a new installation for people to play with and find bugs.
Oh, there you go. Nice. Okay, cool. And then you gave the update for Vampire Framework. That's Z's project. He's kind of swamped right now, but all right. So streaming. Was there anything posted in streaming? I don't think so.
I don't think so either.
Yeah.
Nope,
So,
we're good.
all right, cool. Well, we are streaming, so and there's no new proposals, and I guess we can go through some of the cool resources that were shared recently. So I've shared a few GitHub
That
repos.
book was amazing.
This is I'll give you a
The
little
Book of Secret Knowledge.
tidbit just to scroll through. There it is. Yeah, the table of contents. So there's quite a bit of nice stuff, but if you're looking for shells, it's a good start. But this one's really interesting. If you do have a Mac computer, I've had the issue of, as an iOS developer or as a mobile developer, I like to use a simulator because it's very convenient, and I don't like to go to my phone and touch on my phone. I can just click things with the mouse like that. But the tough part about that is I'm plugged into Ethernet, so I can't actually simulate a phone on cellular or a phone on slow Wi-Fi. So there's this really nice tool that you can install to Mac OS if you have Xcode, network line conditioner. And I'm not going to do it because it's going to destroy the stream, but you can simulate different profiles and even like 100% loss. So if you just want to go in airplane mode or that stuff, but it even tells you the down and up, so you can test more accurate. So if LTE is like that and 3G kilobits, so.
What have you done?
But and yeah, just some other ones like this, Microsoft language. There's quite a bit. So I mean, this one's always flooded with tons of links. So there you go. Hello.
Oh, sorry, I'm controlling your mouse.
So I don't want to jump right into it, but
So our two fun topics today. We're gonna do some really basic mobile development using Zach's SwiftUIKit to get you guys like to dip your toes into iOS development, and then I'm gonna give you guys a little intro to Unity. The stream that we did last week, I took way too deep of a dive into Unity, so I'm gonna bump the brakes on that and just go through some of the basics, just so you guys can see what even game development involves.
yeah, so we'll just dive right into the SwiftUI. So for iOS in general, you're going to be using Xcode, and you're going to need a Mac. There's other ways around it, but it's the easiest. So if I open up my Xcode really quick, for this I'm going to be using anything that's Xcode 11 plus. So if you use Xcode 11, it's fine, but I'm using specifically 11.3. The language won't be any different, but we'll just create a new Xcode project and just a single view app. You really never need to do anything else because you can create anything from a single view app, so the other ones are just kind of presets. So stream SwiftUIKit topic. So we'll just create one. It doesn't really matter any of the settings, I guess. I mean, if you're gonna, make something more like you'd want core data and that stuff, just make sure it's storyboard and not SwiftUI. Since this is UIKit, it is like compatible with iOS 9, but the deployment for 11 is 13 and plus, so kind of double-edged sword there. But at least I can go to Mac. So we'll be writing this now after you create just a basic project. And if you've never created an iOS project, all you get at a single view is just a single view. If you run this simulator, it'll just pop up with a iPhone with a white view, and you can't distinguish anything else because there's only one view. So we are going to add some cool stuff to this, but we're not going to do it in the conventional way of UIKit. So UIKit, if I want to add a label, I'd have to create a UI label, and at this point I need to give it a frame, or I can let constraints set it up. Now SwiftUIKit uses a lot more constraints, and that is like the preferred method of laying anything out. So doing CG rect and anything like that is kind of static. So at that point, it just, if I set it to 50-50, and that's at the top left of this label, if I set the width to 60 and the height to 40, that's fine, but it won't grow at all, so it's going to be stuck at that size. So if I add text really quick.
So if you looked at it on an iPad versus an iPhone,
yeah,
it grows, what he's trying to say.
Yeah, so on an iPad there's a lot more real estate, so we want to say, hey, from 6 pixels over here to 6 pixels over here, then we just stretch. So depending on the device, it's going to be bigger or smaller. But for SwiftUIKit or SwiftUI, you have to do kind of the structure of it. You can add those really easy, but I mean, this structure is already kind of intensive on lines going down, and then I get this, and you see how it truncates. That's because it's not big enough. So we're gonna comment that out, and I'm gonna just import SwiftUIKit really quick. So you just go to File in Xcode 11, and then Swift Packages, and you can add package dependency. This will pop up, and then you can just type in SwiftUIKit and then press enter. If it doesn't pull these up, then you can just put in the URL, which will be in the video description. But use the ZM Ericsson one, and we'll just be using develop since I have a big version that I need to release, and a lot of things are in master, but quite a bit of things are. So I will be mainly showing you stuff that is, but there's just been some conveniences I've added in develop that are really nice. So all you have to do now is import SwiftUIKit, and so this exact same code, we're gonna write it in SwiftUIKit, but it's gonna be different in the sense that it's actually gonna resize or grow and be dynamic for the dynamic text, or it's not going to be here and truncate. So
hey Zach, heads up, when watching the stream it only allows me to go up to 480p. I'm not sure if that's a setting on your OBS or when you're setting up the stream, but you may want to like make Xcode larger and zoom in on the text for at least this stream.
Yeah, there's no option.
Too many settings to remember to mess with.
Yeah. It's output scaled with base. Okay. So I guess I'll just make it. So for this then, all we need to do is just create a label and embed that label inside this view. And now we have the exact same code pretty much, but this is set up with constraints and auto layout, so it's going to be centered right here, but it really takes up the whole space. So if I add however much text, the only thing that should truncate it is the line number, and so we'll see it trail off. So I can quickly just say dot number of lines to 5, and now it won't truncate unless there's 5 lines of text. So you can see, boom, right there. So to do it quickly in here, that would just be number of lines equals 5. And we can, if you just command click on number, you can jump to the definition and you can just see that's all my text does. And that's what a lot of these things are. They just modify it and then they pass the reference of itself so you can chain them. So if I wanted to change the font really quick, and then I can change it to title 1, or let's change the very large title since they're a large title. Whoops. There it is. So now you can just chain them and create what you want, and it just kind of shows. So really quickly, I'll just show one more thing of adding in navigation. So normally navigation in iOS is kind of annoying, but this is more convenient navigation, so I don't really recommend it for too much production or like professional, but it will at least get you started in it. So the only step that you need to do in the storyboard is add a navigation controller, and then we'll just delete this root view controller scene and just right click and drag to here, and we'll just add it as a root view controller. And the only last step that you have to do is drag this initial view and drag it over here. I think you can do a setting where is initial view, but you can also drag that too. So just make sure you save, and we'll go back. And now we're just going to type in navigate, which is just a big singleton that does navigation and other stuff for us. So all we need to do is configure it and pass it in the navigation controller. And now we can set the title, hello world, and then we can also show like an alert message, show an action sheet, show toast, or we can actually navigate. So now that we've configured this up, I can show you really quick navigation. So navigate button actually uses this. So all we need for a navigate button is a destination. So we'll just put a UI view controller, and then we can just do the syntax again. Now normally you have to create a UI view controller kind of, whoops, that's not what I want. This. So there's an initializer in here that allows you to just give a closure for a view. So we can just put in a colored view. Background color. And we'll just make it blue. So now when we go to this one, it'll just be blue screen. And we can just say we push. And now we'll just give it a text to be or a label, sorry, to be push me. And you can get rid of that. But now if we run it, we'll have a navigation button that's destination is a UI view controller with a view, and it'll just be blue, kind of like how we have just a white background. And then the button is actually a label called push me. So boom, and it moves over, and we pushed, so that's pushed into the navigation stack. So we added an element, and we can go back to it. So you can also do the drag. But yeah, that's kind of the intro of that. There's a lot of kind of SwiftUI stuff. If I look at it really quick, you can see that there's a few folders, and MetalKit is one that Sabian and I worked on together to get MetalKit integration. So you could do kind of the similar things of just metal and then pass it something, which is kind of really low level and in-depth, so not for this talk. But we have containers, like a H stack and a V stack, where we can just put elements that automatically manage their height and look or position and according to how many elements are there. There's tons of extensions, navigate, and then all these different views that are just shorthands for other views that you can use. But you don't have to just use this. You can add really quick UI activity view, indicator view, and you can create it, and let's just say we want a large one. So you can do that, and that won't actually do anything, but it'll add it, and you can't actually see it, but you can do start animating. Now this will freak out because technically now in start animating you're turning void, so I just made a loading view that you can give a style, so it's the exact same thing. But if we wanted to actually use this, and my point is we can just create a reference outside, pass it in, and you can still act on it as normal and reference it later. So that's what I've been mainly using, and that'll be kind of outside in the class, so the class would have, you know, a loading indicator and it could show it whenever it wants. So that's the basic introduction, and it's really just more messing around and knowing what you want. Do you have any questions, Sabian, or do you want to switch over to yours?
The only recommendation I would have had is that you kind of explain what each of the things did, but you named them so well that they kind of just make sense.
Yeah, I know. It's like I hate explaining what a label is, and it's like, but yeah, that's the whole point. Is I don't want to type in UI label, I don't want to type in UI button, so I try to just name stuff better. And one last example that you bring up, thanks for that, is UI bar button item. So if I wanted to set this, I can just type in bar button now, and you know, just quickly make, you know, add or an action or add or that stuff. So I just shorten the name. So this is the same thing as a UI bar button item, but that's just a long thing to type out, and it doesn't look that good in code. Like, that's too long. This is too long of a name. But regardless, you can use either one, and it's just kind of wrappers on there. So all it is a type alias for it, and then it's just an extension on that type of UI bar button item, and it just takes a custom view. So they're small, they're meant to be consumable, so you can understand how a VStack works and know what a VStack can do. It has spacing, it has padding, it has alignment, it has distribution, and it has a lot more. But this is really all you need to do is set this normally and then just add it. So it all falls back on UIKit, so, and like I said, iOS 9. So that's it.
Dude, I just got a notification. oneleif, our LinkedIn page, 75 followers.
Nice. There we go. That's rising. All right. So I'm going to let Sabian take over.
Alrighty, we got Unity up. This is going to go a little slow. So, Zach, you're going to kind of have to navigate for me because Zach and I aren't in the same room. I'm screen sharing into his computer so I can do things with it. However, it's being really laggy right now because he's streaming, so he's going to have to be my like clicker as though this is a presentation. I'll stop pressing buttons.
You want me to? Yeah, I'll just get the Unity thing up.
That'd be great. Okay, so for those of you who haven't seen like the old Snake game, it's the one where like you press like you have like 4 directions and then you eat the little dot and then you grow like a longer tail, and then if you ever hit your tail you die. I started out wanting to make something similar for this. That way we just have like one of the most basic games possible because I like to show just some of the most core concepts that Unity has to offer. And for those of you who have no idea what we're doing here, Unity is a game development engine. It gives us all sorts of nice functionality so that we don't have to code like physics ourselves or worry about like timing of the computer or any of that jazz. So what we're going to go through today, Zach, do you want to go ahead and hold on, we'll shrink down some of the UI so it's easier to see. So if we just zoom out here. Okay, it's not low. Zach, I'm gonna have to have you do this. I just want to zoom out and show what the scene looks like. Just right click and then hold S. There you go. Okay. So all the scene is 6 walls that make a cube. And you see how you can see through the walls. The walls are just a plane, so you can only see a plane on one side, right? And then the little circle is going to be our player, and then when we hit start, it's going to spawn like food for our player, and every time you pick up the food, you're going to gain twice the speed, and your goal is to not hit the walls. In the normal Snake, like if you eat food, you get like another piece of your tail. I didn't want to go into that because it would be a little more complicated than necessary. So the basic UI that is Unity, over on the left-hand side, you have the hierarchy, and that shows you what's in the scene. So you can see in our scene we have a light so we can see things, we have our player, we have the UI that allows us to show text, we have an event system that allows us to take inputs, so like if you hold W, it'll allow you to move forward, and then we just have a group that holds each of the 6 planes that is our walls, right? And then I just added some colors to the walls so that way you kind of differentiate them as you move, right? Zach, if you want to just go ahead and hit play and just show them what happens, that way they know what we're doing. Okay, so you start out moving pretty slow, and this little green box, you have to like angle your player, and you'll go hit the box, and when you hit the box, your score will increase by 1, and then you'll move at twice the speed that you were before. The UI is a little janky apparently on the super wide screen of Mac. Are you on your ultra wide monitor, Zach?
Yeah.
Okay, that'd be why. So let's go ahead. Okay, so as he picks up them, you'll see he starts just moving like so fast it's hard to control. And that's kind of the core concept of the game, is like as it gets going so fast, like you have to somehow have like amazing movement, keep yourself from hitting the walls, right? And then I believe even if you do hit the walls with the version I have, so the way this works, right, is the circle is your player, the squares are the things that you're trying to hit, right? And on them are these things called colliders. And Unity handles this for you. When Zach's done with this, I'll go ahead and show you, but basically the colliders are just boxes that surround either your player or the food, and when the boxes touch each other, we know these two things are colliding, right? Oops, Zach got stuck in a wall.
So
All right, we can go ahead and hit pause. Okay, so
you can see.
I'm gonna go ahead and show you the setup of this project, right? So the player has a camera on him, and that's what renders to the game view, right? So we have the hierarchy on the left. Just to the right of that is the scene view. This is kind of like if you're editing the game when it's not running. And then the view to the right of that is the game view, and this is basically what you would see if you were running the game outside of Unity, right? If you were to like build this game and send it to you as an executable, this is what you'd see. And then over off on the far right-hand side is the inspector. This allows you to inspect whatever you currently have selected. So on the left-hand side in the hierarchy, he has the player selected, so you can see all of the things that are attached to the player. And then down in the bottom, we have our project console, and this shows us all the assets and files that we have. And then the other tab next to project is the console, and that'll be kind of like where we can print things like it's a log, right? So since Zach has the player selected, we'll go ahead and use this as an example. On the right side, you see in the inspector, we have components, right? So the first component that every object in a scene has to have is a transform. And a transform just holds the position, so where this guy's at in 3D. And in 3D, you can kind of imagine we're on a graph, right? So a normal graph that you guys are probably used to from math will just have X, Y. But since it's 3D, we need to know their dimensions. We have Z. And then we have the rotation and the scale are the last two components. I don't want to use the word component. Are the last two variables that are inside the transform component. And then in order to show a sphere, we have a mesh filter and a mesh renderer. And a mesh is just a series of triangles. Although you probably can't see it on our sphere, they're actually really tiny triangles. And then attached to it, we have a sphere collider. And basically what this does is, if anything is inside our sphere, we know that we're colliding with it. And then the next component we have is a rigid body. And a rigid body basically allows us to implement physics on this object. So you can see there's checkboxes for using gravity, the mass of the object, all that jazz. And then Zach, if you'll scroll down in the inspector, we have two more scripts attached to the player. And that is just our player script, which manages our player interaction, and then our player aim script, which controls how we aim, right? So as you move the mouse, it changes the direction of the player. So let's go ahead and open up the player aim script, because it's probably the easiest one to understand. So if you've never used Unity before, if you just double click on the script, it'll open it up in Visual Studio. Visual Studio is the editor that you use for editing code, right? So you can see that my player aim script is a mono behavior, which just means it can be attached to an object. And basically all we're doing is in the update function, we are updating the camera's rotation, right? And the update is just called once per frame, right? So if our game's running at 60 frames per second, like most games do, this update function's being called 60 times a second. So you can see all we're doing is we're getting the mouse X movement, and then we're multiplying it by 10, so that way it moves at like a decent speed, otherwise it would go really slow. And then we're doing the same thing for the Y movement, and then we're getting the rotation in a format that's a vector 3, which we're not going to go into that because that's super complex math. But basically what you do is once you're done, you just set my transform or my component's rotation to whatever you updated this frame. And then we make sure that we stick within the bounds of our min and max rotations, so that way you can't like keep looking down and go in a full circle, right? So then if we go to our player script, this is where the majority of the game's management's happening. You're going to see all sorts of things that just look weird. Just kind of bear with me here. So our player has a food prefab, and a prefab is just a copy of the food, so that way we can create new copies of it. We have our player data, which is the data that the player holds, which is just our score and whether or not we've lost. And then we have our play space size, which is the bounds of those walls. So we have 9 units in every direction. And then we have, I'm not going to go into layers right now, that's for collision. And then we can access our rigid body that we saw in the inspector. And then we have our move speed, right? So our move speed just starts out at 1. So on start, so whenever the game starts, we grab our rigid body so we have access to it. We reset the player data so that way you don't save your score from last game. And then we spawn the first food, right? So then every frame, all we do is we update our velocity to where we're looking at, so the forward direction, and then we multiply that by our move speed. So every frame we're just setting our velocity to move forward in the direction that we're looking at. And then we're checking to say, are you out of bounds? If so, yeah, you lost, right? So let's display the loss streak. And then at the beginning of the game, like I said, we reset the player data, which just sets our score to 0 and did lose to false. And then we're going to skip over spawn food real quick because we'll come back to it. So when we on collision enter is a function given to you by Unity, all it does is say, did I collide with something? If so, give me that collision that I hit things. So we say, did we collide with something that is a food? Oh yeah, we did, cool. Let's destroy that food because now we don't want it, right? We want to spawn a new one. So we destroy it, and then we spawn a new one, which just grabs a random position and then creates our food, right? And then we double our move speed, increase it by 20% every time we grab food. Exactly like how you changed that. It was a little too fast.
Yeah.
Yeah, if you double your move speed, you could probably get like 4 food, and then it's like impossible. And then we increment our score by 1, right? So if we hit a food, we destroy that food, we spawn a new one, we increase our movement speed, and then we add 1 to our score, right? Okay, so what happens when we die, right? Well, we go to our score script, right? And all this does is say, at the beginning, we set the text for you lose to you lost. We turn off that script, or we turn off that text, and then every frame we just say your score is whatever it was when we updated it. And if we have lost, set time scale to 0, so like don't implement physics anymore, don't let you do anything, just pause the game, and then turn on our lose text. And then, so losing doesn't work as you think it does, so let me go update that super quick. So let me scrolling, broken. Haha, we'll change this to like 8. So we'll just check if you're more than 8 units away from the center of the map, then you lose, right? Just to show you that this does in fact work. You want to alt-tab back to the game? And the reason it didn't work before is because we checked if we're more than 10 units away, but the planes are at 10 units, and our sphere is 1 unit wide, so you really only get 9 units away from the center. So I just lowered it to 8, so that way if you get like kind of close to the wall, it'll show. So Zach, if you, actually, let's go ahead and move up. So if we go to our UI, we should have our score text, which is it just says new text right now, but it'll update during the game. Then we have our lose text. Then all we want to do is move up our score text, because it's kind of off the screen right now. And I don't think that's it. You want to just set that to like -200?
Okay.
There we go. Okay, now you can see. Okay, so now Zach gets play. It plays the game. everything will behave as expected.
Yeah, and this is a good talk about Unity has the same things I was kind of talking about for SwiftUIKit, where it has layouts and that stuff. So if Sabian laid it out correctly, it should always
Like
be on the screen.
The score would update correctly. Like the text box itself would resize based on the screen, right?
Yeah.
I didn't take the time to do that because I wasn't too worried about making that work.
Yep, but that's a great example.
We can do that in a future video. So yeah, Zach, if you want to just like walk into one of the walls to show them the lost screen and that you don't move anymore.
All right. Help.
The team viewer is just not updating at all.
Yeah, that's team viewer for you.
Sorry, I'm watching the stream to catch up. Ooh, okay, yeah, okay, cool. Yeah, it's just, hey, you lost, woo, and now you can see he can still move because we didn't, like, prevent that, but you can't move anymore because we set the time scale to 0. So that's, like, the very basics of Unity. We could go into so much more detail on all of those things, but that's just such a very high-level overview. I'm not going to explain, like, why the code works the way it does because you guys just don't know C# programming language. But we made, you know, a cool little game here.
Yeah. So.
And we don't really have anything in the stream chat, so we can kind of just chit chat here.
Yeah, no, I think that sounds good. I don't really care what we talk about now.
The only thing I didn't go over, I guess, is that that's unnecessary information. I'm just gonna make a tutorial series on how this is made, like from scratch. That way, you can watch this video, you'll be like, oh, that's kind of cool. I want to like actually learn how this is made, and then I can explain the whole thing because this will be small enough that I could make it in like one 30-minute video.
There you go. Yeah, no, that sounds good.
One day I'll be as good as my Lord Brackies.
Oh, jeez, that's gonna be a bit. He's too good, man.
Yeah, go to YouTube. Oh wait, you're already there. Look up Brackies if you want to learn about games. His videos will forever be better than whatever I'd want to produce in my life.
Oh, don't say that. That's just sad now.
Well, man, what do you want to do? You could show him the game we're working on if you want.
Oh, I was thinking we work on a kata together.
Ooh, I'm down for a kata too.
Let's do that. Should be less intensive on the stream. Okay.
So, I know I covered what katas were a couple streams ago, but just to reiterate, a kata is Japanese for training exercise or something along those lines. I don't know Japanese, but in YouTube turns the capital O dot lower O to like an emoji.
Huh. Is it streaming again or no?
It's loading. It's thinking. Still thinking. No, it's just a black screen.
Sweet, and we're back. That's OBS for you. You gotta be careful with what you choose to stream with. Alright, so we're back.
That's what YouTube is thinking. Let's make sure it's still... Alright, cool, we're back up.
You doubt me? Alright, take it.
Alright, so we're gonna go over to kata. I don't know what they did and didn't hear. We're gonna do a programming exercise. That's what it comes down to.
Yeah.
So they're ordered by Q. I have no idea what Q means, but it's difficulty levels, right? So 8 is the least difficult, 1 is the most difficult. If you try and do 1 Q, you're gonna regret your life decisions.
Yeah. No.
8 is like too easy. 6 would take too long, so I'm just gonna do a 7. And then you can. So we group it by 7, and then we can choose a programming language. Zach, what do you want to do? C#, Swift, Java? You want to do Java? Because we can both do Java.
I would rather do C or shell. But let's find a topic. I mean, I don't care which one we do. I think we can do either one or one after the other.
Moves in squared strings sounds pretty easy. Did I click? Ah, I did. Okay. Okay, this looks like a little bit too long to read for stream. I want something super simple that we can just kind of get into the meat of it.
Yeah, there you go.
Complementary DNA. Team viewer, please.
You could do it. You could sort them by most completed, just to get like the simplest ones and get a good example on the stream, or.
This one does actually look really easy.
Oh,
you just revert. You just grab the opposite, right?
Yeah, this one's easy. I think. Have I done this one?
So,
Yeah, I've already done this one, but I've done it in Swift, I think.
Yeah, it says train again. Alright. What language do you want? We got C#, Java. I don't know Kotlin well enough to feel comfortable doing that. We can do it in Shell. Or Python. If we had any viewers, we'd say, what should we do it in? But, Zach, make an executive decision here.
Swift.
Alright, let's do it. Wait a minute. It's not there.
Oh, did I do this one in C then? Which one did I do it in?
Does it not say? Hold on, let's hit try again. What does it put you in?
Go check out the languages. Oh, past solutions. Oh, look, I have a past solution. What is this? Ah, my eyes.
It's in C.
Yeah, it's definitely C. I did a ton of C.
I saw a star and I was like, oh, that's not any language I know.
Come on, it's C.
Alright, well, okay, just to prove that like this is how things work. So if you select a language, it has like a compiler built in. If we go ahead and paste the solution and hit run sample tests, what it does is there's tests that it shows you for sample that basically says, does your code work correctly? Let's pass in some examples to see if it works as intended. And if it does, it says, oh hey, you did it. And then it tells you, does it not tell you how long you took? Oh, there it is.
Yeah.
Then it'll tell you how long you took. So that way, even if you make a solution, you can find you can work to try and get a faster time. And then you can also unlock solutions. Haven't you already done this?
Yeah.
Attempt. Submit final. So why don't you submit your final? You see the highest rated solution, so you can see like, oh hey, this one's cleaner than Zach's apparently.
The one below it's cleaner. Ooh.
You think so? Because this is pulled out?
Well, I don't know. At that point that you actually have a structure, like it's easier to add to a structure than to add another case, I think.
That's probably true. That, and it's more reusable.
Yeah. But
okay, so we'll go back and
there's
actually do this.
Yeah, there's tons of examples like this in any language. So let's do this one in C# then.
Hey, I'm in. Okay, so I don't know how many backspaces I hit.
You want to try to one-line it?
Oh my goodness. Okay, hold on. We'll do the long solution, and then as you do the long solution, I'll come up with the one-liner, I'm sure.
All right.
So, for those of you that are unaware, there's like built-in functions to most languages that allow you to do what are called high-order functions. So, like, rather than doing a for loop, like your normal, like, for x in y, and then doing, the multiple lines where you do things inside of it, you could do, like, y dot for each do this thing. And then you can come up with clever solutions to figure out how to do the entire problem in one line. It'll look super ugly and complex, but it will work.
Then there's even syntax and like rules, or like kind of language rules about writing with one line that if you did this something, and then I used a function on it, like map or that stuff, and then I like filter, and these are more like Swift ones or whatever, but the syntax for most or that stuff is to break it like this. And I don't know if that's the same for you, but a lot of places kind of do it as steps then. Instead of one big line, it's steps. So I'm going to do this first, and then this, and then this. So.
Okay, so I'm gonna approach this with like the dumbest solution possible, right? We're gonna just like you guys should do in coding interviews. when people ask you a question, you should immediately try and solve it, and then we can go back and prove that we know how to make it more efficient. But you want to first prove that you can solve the problem and not make yourself look dumb by trying to come up with the most creative solution right off the bat. So, what jumps out to me as the best data structure for this would be a dictionary. Because a dictionary, also called in other languages as a map, just maps from one thing to another. So we're going to map from A to T, from T to A, from C to G, and from G to A, right? So that's super simple, right? So we can do dictionary. We don't have autocomplete. All right, well, I'm going to have to remember the syntax. So we're going to go from string to string, and we'll call this our lookup, and this needs to be a dictionary. I think I actually have to add the types here. I don't remember. It's been so long. Oh, no, I have insert on. Okay, so we have this dictionary thing, and we want to add to it. I don't remember if it's put or add. It's been too long. I know it's going to be capitalized because that's the C# syntax. But we're going to add T maps to A, and then I'm too lazy to write all this again. If you're a programmer, you should be lazy too. And now we can go fill back in the values. Okay, so we got boop, A, G, and C. Okay, so what this says now is we have 4 things inside this lookup table. If we say lookup dot get T, so like if we do, whoa, all caps, lookup dot get G, what do you think it would return? Well, we get whatever the key is and the corresponding value, so it would return C, right? So now what we can do is we can just loop over each of the characters in here and say, for this character, get the opposing one, and then add that to our new string, right? So we can say for each character, if I can spell, in our DNA string, we want to have I always like to do super simple and have whatever the thing we're going to return called to return. It makes it very clear what we're doing with that thing, right? It's going to be the thing that we return at the end of this function, which is going to be of type string, right? So at the end of the function, we know we're going to need to return, right? Okay, so now we need to figure out what in the heck to return is. So what this for loop is every iteration of this for loop, we're going to grab one character from our string, right? And then we're going to say lookup dot get character. Ooh, that's not going to work. It needs to be a string. For each, I did this the dumb. Get character dot to string. Okay, I have no idea if this is going to work. I've never done this before. Okay, so we get the corresponding characters. So if it's T, we'll get an A. If it's an A, we'll get a T, and so on. And then we'll say to return plus equals that thing. All right, I have no idea if this is going to work. The type of namespace dictionary cannot be found. I believe we need to import using system.collections.
That
And I
seems
don't know
right.
if it's system.collections or system.collections.generic. I can never remember. We'll do both. Dictionary does not contain a definition for get. Okay, alright. This is me not having autocomplete and being off with this. G#. I'm gonna do what every programmer does and Google it. It is.
Can't just access it by the square brackets?
Oh man, you can.
Boy! C# legend right here. Stand back. I got this. Bum bum bum.
Okay, so you can access it kind of like it's an array, which is a weird notation, but
Subscript.
that's what it is. Ah, all of our tests pass. Everything works. This never happens. Oh my goodness! But did you see Zach's C solution ran at 800 milliseconds? Ours runs in 2.7 seconds.
Yeah. Wow.
So ours is 3.5 times slower than Zach's.
Yeah, but mine's using C versus C# too, and that might be also network. I don't know. But the interesting part, I would like to point this out because this is a really good example of a dictionary. Dictionaries get instant lookup, which is really nice. But the reason the C example that used switch was on top is because a switch is also like a dictionary, where it has instant lookup of the type. So you could get away with that too.
Slower is that I'm trying to convert my string to a character, and I'm converting my character back to a string. I'm assuming that's what's making mine take so long. You know what? I'm curious. Does this even work? Cannot convert type car to string. What? Oh, so it assumes that if you're trying to loop through a string, that you want to use a character. Okay, so let's. Just I'm curious about the performance here. I don't deal with performance a lot because everything just kind of works.
Famous last words. Man, words that have never been in production. Oh.
Okay, this is gonna be awful syntax. Don't try this at home, kids. Argument 1 cannot convert from line 7 to look up at string.
Yeah, those are chars or characters.
Oh yeah, this is gonna be a character. Okay. I'm still curious. I still wonder if this for loop makes it quicker. It did not. Okay, yep. So it is most likely this toString that's making this slow, which would make sense when my logging in Unity, my custom logger is so slow, because they all have custom toString functions.
Well, so the more interesting part is to remember what we have, submit the final, and check out the top one, and we could potentially see how fast that is.
Let's do it. Dude, I bet they have a one-liner for this. No? Ooh,
oh,
that's
yep.
So nice.
Yep.
They
See,
nice
they just go with the basic switch, and then so this is the nice part too about the switch is that you get that default case, and at that default you have the chance to throw an exception, which you should have error handling and a technical or that stuff. You should think about it or at least ask. And then the next one is a dictionary.
If the test passes in something that isn't A, T, C, or G, it'll freak out and say, "Dude, what are you doing?" Whereas our solution would have just done nothing. Ooh, there we go. Now they're using those high-level functions. Okay, I want to see how much faster theirs is. I'm curious. I think I copied it. Yeah. Run sample. Okay, theirs isn't terribly faster. They beat us by...
It's probably just string manipulation, yeah.
Yep.
Yeah, no, that's weird.
So what theirs adds that makes it more costly is that when they call get complement of the character, they have to add this function to the stack and then remove that function. Wait,
theirs is more costly? I thought yours was. Sorry.
What's that?
Theirs is 2.4 and yours is 2.2?
Theirs is faster than ours.
Oh.
However, the reason it's not blazing fast is because they call another function, right?
Well, no, it's because it's C#, right? At some points it's...
Also true, yeah.
Yeah.
C# is just inherently slower than C unless you're a really bad C programmer.
And that's the point. Is you can't expect the same performance as that C example. But I guess this is the almost like the minimum at some point for this, if this is the most upvoted.
So you can see the fastest solution that we found is still 3 times slower than the C solution that Zach had.
Yeah, that's crazy. But should we do another? Just one more?
Sure, man. We're at an hour. We can end whenever or keep going.
Okay.
I need to check and see if... Never mind.
Function 1, hello world.
I'll leave this one up to... This one's your turn. Hello world.
I don't know.
Hey, look, Fizzbuzz.
Oh, wait. Fizzbuzz.
It was multiples of 3 or 5.
Oh. A floating point system.
Dude, I have to know, what is Count the Monkeys?
I did a 4? What was this one that I did the 4 in? It had to have been Swift,
Oh
right?
my goodness, that one had to take forever.
Wait, what is...
And you take in seconds, and then you have to output it in like hours, minutes, seconds.
How fast was this? I'm so curious now.
That is such a long solution. Not that like time formatting is an easy...
Yeah, but at least I used switches in one case. This other one, I don't know. I think at some point I just wanted to get it solved, so I'm not saying it's the best. But it did pass the... Yeah, there it is. But this is always good to work on and then reduce the time. But, jeez. That's long.
Unless, however, you're coding like 800 if-else statements. Don't do that.
Yeah.
Find a better solution before you do that.
Yeah, there's a better way. If you're only doing 5, then it's easier to reduce after some point, and 5's an arbitrary number. I mean, once you've gotten bored of typing them, you should probably stop. Yeah. Are they the same? Let's do it because this is a 6 here.
What's a 6?
All right, I'll let you take it from here.
Whoa. Given 2 arrays. Enclosure.
yeah. Special case.
This one's too much effort for 8 p.m. Even have C#.
Hey.
Damn it, now I have to do it, don't I?
And you can even look at my previous solution if you really want to, get through it.
Okay, so all you have to do is check if B is all the elements in A squared, right? This doesn't seem that bad. I'm gonna be a lazy pile. And we're gonna write this the dumbest way possible.
Alright.
String, B check. For each integer I in A. These variable names are atrocious. Don't name your variables like this ever.
Oof. Lead by example.
What's that?
Lead by example. Why don't you just name them good right now? Ooh.
We'll call this like it.
You can name I. Oh my goodness, you can name it I. See,
Check. Yeah,
that's like the one example where you can do that. B check, I don't know.
I'm gonna call that two check. There we go. And then what we're gonna be doing is we're gonna be saying if a 2 check. Oh damn it. String A converted and B converted. How about that? I can still name this better. I'm blanking. I'm sorry. So we're gonna have at the end is 2 strings, one that's A and one that's B, and B is just gonna be turned into a string because we need to check if B. Yeah. Okay. Cool. So if A converted is equal to B converted. Whoa! What did I do? the same, then return true. Otherwise, otherwise return false. Okay, I don't have like auto indent, so I'm gonna be lazy. Okay, so for each one of them in A, we're just gonna say A converted, add in I dot toString, and then we have to add on a comma, don't we? That's annoying. I'm just gonna remove the commas at the end, and then B converted. Oh my goodness. Hard my incapability to program here. Square it dot toString plus a comma. Okay, so now we should have both strings, and then at the end we just do I don't know how to remove the comma. I know that I can concatenate strings. How do you just like remove the last one? I don't have Visual Studio here to fill in all this crap for me.
I don't know if it'd work anyways. Does that handle for like regardless of the order?
What?
What? Well, you're only taking from A, right?
So like the A converted will just be this, right? Obviously.
Yeah.
And then I'll have an extra comma at the end, which I'll take off. And then B converted will just be. Wait, why isn't this one square?
Regardless of order?
That's what I get for not reading it.
This is a good example of asking questions helps.
So if you were in an interview with Google, you'd say, are there any conditions that I have to add to this to... Oh my goodness, I'm upset with you.
One-liner!
Function magic.
I think it... Well, technically... I think it's Swift 5.1. Give me Swift 5... Oh! In Swift 5.1, I could write that. But this is going to error out. I wonder... And string manipulation, or any array and that stuff, you have to be careful with time, because it's, you know, the more you map over it, like, okay, that's, you know, that, you know, quite a bit. But if you wanted to make this easier to read, you could do sorted by. This gives me a headache, though, right here. So I'm just checking if A map over is equal to this. But yeah, sorted is a very nice one, but it's very costly. So the fact that I'm using a higher order function like this, I have to sacrifice cost by just calling some sorted method and calling some sorted method. So, but yeah.
I just realized I was trying to do string comparison and it was completely unnecessary.
Yeah, I didn't say anything.
I should have. I was like, oh man, I can just hop into this. It'll be fine. No, that was the worst. Yeah. You can do a very similar thing in C#. I just don't know the name of the link functions off the top of the head.
Yeah, you really have to know them.
You just have to use them a bunch to keep them like fresh in your memory.
Yeah.
I have all the Java ones fresh in memory, but.
Wonder what this one was. Ooh. Ruby.
Stop spinning my words.
Yeah, see, I do a ton of random languages. It's like, why did I do this in Ruby?
I don't know.
Alright, well, is there anything else? I think we went through quite a few. I think those were some good examples.
Yeah, man, this is a perfect stream. I just had to make a fool out of myself at the end.
I love it. No one watched until,
Yeah,
here.
nobody watched. It doesn't matter. Life is pointless.
Alright, well, thanks everyone for watching.
And those that watch after the stream is done.
Yeah.
We should put a...
Bye!
When we're done, we should go back and put a timing